Today we're going to talk about graphing exponential functions. Because logarithms are the inverses of exponents, the inverse of an exponential function, such as y equals 2 to the x, is a logarithmic function, such as y equals log base 2 of x. This means that the graph of a logarithmic function is the inverse of an exponential function. The graph of these functions can be seen on the right, where the exponential function is in blue, which we already graphed using a table, and the logarithmic function is shown in red. To graph the function f of x equals 1.25 to the x and its inverse using the values -2, -1, 0, 1, and 2, we're going to make a table. So we put the x values at the top, the -2, -1, 0, 1, and 2. Using a calculator, we can plug these in. 1.25 to the -2 is 0.64, 1.25 to the -1 is 0.8, 1.25 to the 0 is 1, because anything to the 0 power is 1, 1.25 to the first is 1.25, and 1.25 squared is 1.5625. Now we're going to graph these points. The first one was -2.64, second one -1.8, 0, 1, 1, 1.25, and 2, 1.5625. Connecting the dots, you get the graph shown on the right. To get an inverse, you just switch the x and the y values. So we put the x on the top, which is what was the y values from the previous one, and we put the x values from the previous one on the bottom as our f of x. Now we can do the exact same thing and plot these, except now 0.64 has the y value -2. The 0.8 has a y value of -1. If we graph all of these, we can see the inverse graphed on the same set of axes. Notice that f is the original and f to the -1 is the inverse. Both graphs are graphed on the same set. So let's look at example 2. We want to graph the function f of x equals 1/2 to the x and its inverse using the same x values. So first we make our table, and we plug in -2, -1, 0, 1, and 2. Plotting those, we get the graph to the right. Now to get the inverse, we do the exact same thing. We switch the x and the y. So we switch the top and the bottom, and we can graph the same points. And notice that again we have f as the original and the f to the -1, the inverse, graphed on the same set of axes. So you can find all of these points for -2, 2, -1, 1, 0, 1/2, 1, 1/4, 2, all on the graph of the inverse, f to the -1. Our third example is going to be similar. We are graphing the function f of x equals 3/4 to the x and its inverse using the x values -2, -1, 0, 1, 2, and 3. We make our table and we plug in each of the values. -2 gives us 16/9, -1 gives us 4/3, 1 gives us 3/4, 2 gives us 9/16, and 3 gives us 27/64. Remember, we're getting these by plugging the x into the original equation. So this would be 3/4 to the -2, 3/4 to the -1, 3/4 to the first, 3/4 to the second, and 3/4 to the third. Now we graph the points, x, y, and this is the graph we should get on the right. To get an inverse, you switch again the x and the y. So we switch the top and bottom rows, and then graph these points. Notice that the blue line is the original, and the red line is the inverse.